Today our topic is about the banking of road clouds including friction, the minimum speed to prevent downsliding. First we are talk about the minimum speed to prevent downsliding. So this is the speed which is required to prevent the slide to in the circular path down. So the for free body diagram for that will be like that. Free body diagram will be for that will be oh no will be like that. The free body diagram. This is the normal force. Let the thickness will be small. This is the normal force, and this is the weight which is splitting in that way. There is a theta, and there is the mg cos of theta. Mg cos of theta. While in that direction, the force will be mg sin theta. Force will be mg sin of theta. Mg sin of theta. Then that is the normal force along y-axis. This is the x-axis and this is the y-axis. Sorry, this is the n normal force and the axis is this is the x-axis and this is y-axis. In this case, the friction force will be upward, preventing the car because the potential of the car is downward. This is the friction. And what about the centripetal force? Centripetal force will be like that in this direction, and this is also will dividing into two components which will f fc cos of theta, fc cos of theta, and fc sin of theta. fc cos of theta. This is fc cos of theta, and this is fc sin of theta. This is the whole scenario. So the derivation and the equation from this system is written below like that. So we are applying Newton law on the x coordinate of the system that summation of forces along x axis is the mg sin theta minus fs is equal to mg sin of theta is that and fs in that direction. So the mg sin theta and direction of fs is opposite. So we write minus sign, and this will be providing necessary centripetal force which is fc cos of theta. Then this is the equation 1, putting the value of fs which is equal to mu s coefficient of friction into normal force, finding normal force by Newton's second law, applying on the y coordinate of the system which is let's see the forces and y coordinate which will be n minus mg cos of theta and fc sin of theta. There are three forces along y-axis which is mg cos of theta plus mv square sine of theta minus n. This implies that n is equal to mv square sine of theta plus mg cos of theta. Putting the value of n into equation number 1, we get that equation, and solving the equation for we get that the minimum velocity final equation. So let's see the maximum velocity to prevent sliding is maximum velocity to prevent sliding outward the circular path. Here is the main thing is the force of friction which is opposing the car to move in a circle. In this case, friction will oppose the car to move in a circle because the potential of the car will be in this direction. The potential of the car will be in this direction. Potential of the car. The car is trying to move outward the circle, but the friction force is pulling the car. Frictional force and mg sin theta and force will will oppose the car to move in that circular path. Potential of speed, this is the potential of the car in that direction. So the friction force is always opposite to the potential speed. So in this case, we will take the frictional force in that direction, which is very important thing. And the whole calculation in that case will be same as the past case, but only the difference is that F force of friction. So here consider the centripetal force, which is that Fc, which is all is broken into its component Fc cos of theta and Fc sin of theta, and that is the normal force, and that is the weight x component of the weight, which is mg cos theta and mg sin theta. So applying Newton law on the x coordinate of that system will be mg. Let's see the forces on the x coordinate of that system is what are the forces? It is the forces are mg sin theta, F static friction, and the Fc cos of theta. So Fc cos of theta is the is the dependent force, which is not which cannot exist independently. This is also this is provided by any other force. So the summation of these two forces, which is frictional force, static friction, and mg sin of theta, provide us with the necessary centripetal force. So Fs will be equal to mu s n normal force, and in this case the normal we will need normal to solve the equation. For normal force, we use Newton's second law on the y coordinate of that system. Let's see the forces in the y coordinate of that system, which are normal force mg cos of theta and Fc sin of theta, which is n. This implies that n is equal to mv square by r sin of theta, which is Fc sin of theta, and the vertical component of the centripetal force plus mg cos of theta, horizontal component of it, n is equal to that. Putting n in the equation 1, which is that equation. This is equation 1 and this is the n. Putting n in that equation will give you we will get the resultant equation like that. There is a resultant equation mg sin of theta into mu s. This is the value of n. This is total n, which is n, and it's equal to mv square by r cos of theta. After solving that, we will get that v maximum is that velocity after which this is the limited velocity, that after that velocity the car or any other substance will move outward from the circular path. So in the under root rg rg, from that we can assume rg sine of theta. I hope you will solve the equation by yourself, because there is not any complex equation. There is only a simple equation. Solve this equation only for Vs. Just sin theta plus mu s cos of theta divided by cos of theta minus mu s sin of theta. So this is the equation. This is the resultant equation which we want for to find the maximum and limited speed for moving in a corresponding circular path. So thanks for watching, and please subscribe my channel for more and more learning opportunities.